Hello everyone, my name is Jose Alarcon. Uh, we're starting Objective 1. Objective 1, design and complete a robotic system, right, that you're going to use for World War situations. So what I ended up using was, if you see here, it's called a motion saver, and this motion saver is what it's gonna do is that it'll wrap around the patient's leg, as you can see here on this picture, and it's gonna prevent patients from having sores, right, amputees, right. So this will give them like a limit, like, hey, you're not gonna be able to go too far walking, running too much on the left side, the right side, and it'll just that's what it's for. The next one is going to be the traffic light system, obviously, because we use this on a day-to-day basis, or we see it. Sorry, in a day-to-day basis, and in doing so, you know, this is what we're using here. Okay, because it's going to be, so here, if we see a small demonstration video, I am going ahead and I will fast forward it. You can see it's going to be green, red. It's going to be for walking. It's going to be yellow, and then now it's red, blue, green. Obviously they're going to be go, right, like a traffic light system. All right, now it's off to the next one. This one's implementing a simple processor. So what I ended up using was using the Larson scanner. So the Larson scanner, what it's going to do is that this is going to be, if you've ever seen the movie Knight Rider and stuff, and you can see the lights here are going to be moving left and right, okay, just like the movie, the show. It's been a while since I've seen it, and that's what the simple process is, because it's pretty easy. The other one was a traffic light system. This one wasn't too bad as well. Again, you're just putting the wires, the resistors, and also the LEDs, right? And you're also using specific side of the Arduino, which are the port Ds and the port Bs, right? As you can see here. Okay. Objective 3. Demonstrate embedded design skills, not including to microcontroller, schematic design, printed circuit board, right? So what I ended up using, again, was the motion saver. So the motion saver, I was able to use the IMU that's built in. That IMU is called the accelerometer, or the three gyros, and that's what I ended up using for the motion saver, because you want to be able to have guidance for these amputees to prevent them from getting pressure sores, obviously. So that's one I did there, and another one is a 7-segment display. And here I ended up using a dip switch here. And with this dip switch here, I'm able to change the numbers, so you could do 0, 1, 2, 3, 4, 5, 6, 7, right? And let me see if I can fast forward it. Oh no, watch right here. I'm gonna be ended up changing it. It's on 1. See, now 3. Every time I push any of those numbers, it's gonna change. 7. Objective 4: apply knowledge of transducers, actuators, hardware, and software development. Okay. What I did was another one. I ended up using the external interrupt, right? I mean, ended up using hardware and software inside to make this happen, right? And in doing so, I was able to use a passive buzzard and a push button, because with the actuator, I'm able to push a button and the light comes on, and also the buzzer. Another one is a simple Simon game. The simple assignment game was, I don't know if you guys remember, as a little kid, we used to play you'd have to have a memorization what the other person's going to say from the while back. So same thing with the simple assignment game. You're going to be able to get the numbers, the colors right. If not, obviously it's going to blink on you, and that's where you get it wrong. So let me go ahead and start the simulation right here. You'll see the demonstration right here. See, green, blue, green. So that's all you're doing, the simple Simon game. Objective 5: design and including advanced digital logic, signal processing, high system. So what I ended up using was a motor control. The motor control, I was able to use a DC motor. Again, I ended up using L293D. And what I ended up doing was coding it to where you go forward and go back, okay? And also give it a 5-second pause. And I'll fast forward it right here. Boom, there's a 5-second pause. And another one was I ended up using was robot behavior, but you know I'm only limited with supplies of the Arduino, so I didn't have 2 potentiometers. And what I ended up doing, you were able to control the speed off of both motors different times, you know, which is pretty neat. You know, you could go one super fast or the other one kind of slow. You know, that's the way to do it, you know, to be able to control it. Look, see, I was able to, let me go back here. I was able to have this one at a particular speed. Then I raise this one up a little bit. And then this one faster. Okay. The next one was using an autonomy robot, right? Implement algorithms. So I ended up making a robot navigation, right? Nova robot navigation ended up using the ultrasonic sensor L293D and Arduino. And the point of it was to, like, whenever it sees an objective, it's going to turn left or right, right? So that's what I did. But what I ended up doing was I ended up advancing it. So I ended up using a servo motor as a neck, you know, so you're going to have the sensors as the 2 eyes, and it's going to see back and forth. And what's it going to do is that it will see something stop. It should look left and right and reverse and then continue forward, right, until it sees something, and then it'll do it again. Sorry, I just placed my foot there, you know, just letting you know how it's searching with the neck, as a servo motor should do. You know, I only did a 80 degree. Obviously, I didn't want to do 360, you know, to pull the wires out. Sorry, this was, I ended up moving it because I was just hitting the mat and the carpet. So the sensor reads up to 20 centimeters. It's going to stop, reverse, and again, go forward.